Welcome to my channel. The video describes implementation of a 4-bit shift register using D-Flipflop in Vivado tool. I have written the Verilog program of a D-Flipflop with inputs D, reset and clock. The output of the flip-flop is taken as Q. I want to implement a 4-bit shift register, a serial in, serial out, serial in, parallel out. In order to implement this shift register, I make use of the D flip-flops which are cascaded in series. To implement this, I make use of this D flip-flop as a RTL. Create the block design. Click OK. It opens a new canvas. Within this design area, add the source, which is a D flip-flop. Right click, add module, select the D flip-flop. To implement a 4-bit shift register, I require 4 D flip-flops. You can add modules. Add another 2. A total of 4 modules are required. All the flip-flops are in a synchronous mode. It is connected to a common clock. Right click, make it as external. Change the properties. External port properties and make it as clock. Connect all the clocks. In a similar manner, make this input as external and call it as serial in. Yes underscore in. The output is taken at the last flip-flop and make the output as yes underscore out, which is a serial out. Make the reset pin as external. You can change or you can keep the same. Connect all the reset pins. Now the design is completed. Once the designing is done, click on regenerate layout and finally click on validate the design for errors. The design validation is successful. Now this is the RTL design using the blocks of a serial in, serial out. Once the designing is complete, go to the sources, convert this block design into Verilog using right click, then select create HDL wrapper. This will convert this block design into Verilog. It updates the design. Still it is updating. Now the block design is being converted into Verilog with the extension .v. Now it has converted the block design into Verilog. Double click on it to see how it is converted into Verilog. Now to check the design, click on Run Simulation. Without writing the test bench, you can run this simulation. So I want to have this reset at the top. Let me maximize. Apply the clock. Right click. Force clock. Leading edge 1. Trailing edge 0. With a period of 100 nanoseconds. Make the reset signal to 1. Why I am making it as 1 means, you can see the design. The block design, it has a complemented form already, reset signal. So I am giving it as 1. 1 applied means it is makes it as 0. So I'll apply the 1 here. Now you apply the clock with 1, 0 and make the period to 200 nanoseconds. I'll select 100 nanoseconds to see the steps. Few more steps. Finally, see that when the clock is high, reset is high, serial in, it is shifting. Serial in this case, right from this, you can see the remaining period is delay. It is shifting one after the other. Serial in, serial out. It has a delay. I can go back and convert this design into serial in, parallel out. Only small modification. You can take the output here. For that, create the port. I'll name this port as Q0. A port is created. Let me delete this. We'll come back. Change this to Q3. Make it this as external and change the port to Q2. Make the connection back. Similarly, make it external. Change the properties to Q1. Connect this back. External. Make this to Q0 and connect it back. Regenerate layout. It has 4 outputs with single input. As you see in this diagram, with single input, 4 outputs. 1, 2, 3 and 4. So regenerate layout. Click on validate design. Again, right click, create the HDL wrapper. OK. Now it is converting into Verilog. The reset signal has to be a 1 because it is already complemented. Conversion is done. Click on run simulation. Now it is ready with the simulation. This time you can see there are 4 outputs. Let me throw this up. S in. Apply the inputs. Right click. Force clock. 1, 0 with a period of 100 nanoseconds. Force constant. Make it as 1. And S in. Force clock. 1, 0. And if you want, you can change the period to 200 nanoseconds. Just run for 100 nanoseconds. See the changes. Again 100 nanoseconds. You can see that these are the parallel output from each flip-flop. If you want more simulation runs, you can click here and check the waveforms for Q0, Q1, Q2 and Q3. This is the implementation of a serial in, serial out as well as serial in, parallel out shift register.